Hello students. Previously we did homogeneous linear differential equations of the form f d d dash operating on z equals function of xy. I told you that there are two rules. One is general rule. For finding complementary function, you already know how to find the complementary function. You have all the factors of this type, d minus m d dash operating on z equals 0. So when you have factors of this type, you have to write the auxiliary equation, then the roots of the auxiliary equation, and then the answer in terms of functions. Now, if this function is of the form ax plus by, then particular integral is function of ax plus by f dd dash. In this case, you have to replace d by a and d dash by b. This we have done. You have to replace d by a and d dash by b and integrate this function of, you have to treat it as a function of v and integrate as many times as the order of this differential equation. If it is n, so you have to integrate n times. This I have already shown. And if there is a case of failure, then you have to multiply. Is a case of failure of order 1. Say you have a raised power x plus y upon d minus d dash. You have to multiply by x. If it is square, then x square by 2 factorial and x cube by 3 factorial, so on. Just like what we were doing in first semester. This was about the homogeneous part. I have not touched any non-homogeneous part. Now today I will be teaching you non-homogeneous partial differential equations. Okay. Now I have again f d d dash operating on z equals some function of xy. Now see, if you have a homogeneous part d minus a d dash operating on z equals 0, you know what is the solution. This is function of y plus mx, right? Now you have another part. Say this is m and this is, say, b. Now this is not homogeneous. This was homogeneous because this was d and this was d dash of order 1. Now here you have d raised power 0. This is not a homogeneity part. So how to solve this equation? See, this is p. If you remember, d is del z by del x. This is del z by del y. And this is bz. So this is p minus m cube equal to bz. So what is the auxiliary equation? dx by p. This is pp plus qq equal to r. Again, Lagrange's linear form. dx upon 1, dy upon minus m, dz upon r, it is bz. Taking first two fractions together, you will get y plus mx equals c1. Taking first and last fraction together, what you will get? dz upon z equal b dx. Okay, now let me integrate it. Log z equal bx plus log of c2, or log z minus log e to the power bx equal log of c2. So z minus e to the power or I can write it as log z equal to log c2 e to the power bx. So what is your z, or what is your c2? Your c2 is z e to the power minus bx. So my solution is either c1 as function of c2 or c2 as function of c1 or function of c1 comma c2 equals 0. If I will take c2 as function of c1, then my solution is z e to the power bx equal function of y plus mx. So what is z? E to the power minus bx function of y plus mx. So this is it. If there is a factor which makes a differential equation non-homogeneous, what you have to do only, you have to multiply by e raised power minus bx only. If it is plus minus b, this is minus b, this is minus b over here. Is it okay? This is bz, d. Yes, it is okay. So this is it. So if I have a non-homogeneous part, this I have to multiply by e raised power that part. A, whether it is A, whether it is B, whether it is C, you have to multiply by that part only. This is it. And for particular integral fxy upon f d d dash. Now I will take a particular value, that is function of ax plus by. If I have function fxy of this type, f d d dash, then what I have to do is that I have to use all the rules used for ordinary linear differential equations. That is, when you had e to the power ax plus by, e raised power ax upon fd, you were replacing d by a. So here you have to replace d by a and d dash by b. For this you have to replace d by a, d dash by b. This is it. If you have sine ax plus by or cos ax plus by, f d d dash, there will be d square, there will be d dash square, there will be d and d dash. What you have to do is that sine ax plus by, replace d square by minus a square, d dash square by minus b square, d dash by minus ab. What you are doing in ordinary differential equation, if it has sine ax upon fd square, you are replacing d square by minus a square. Same is the case over here. You have to replace d square by minus a square, d dash square by minus b square. This is logical. This is very easy. You can see the notes, because you see what is differentiation of sine ax plus by. This is a partial derivative function of two variables. You are differentiating with respect to d. D means you are differentiating with respect to x. So this is once a sine means cos ax plus by. You differentiate twice. This is again minus a square sine. So you are replacing d square by minus a square. If you differentiate with respect to d dash means with respect to y, and this is sine, this will be minus b square sine. Simple. Just like we were doing in first semester. So you have to use all the rules used in first semester. And if you have a case of failure, f of a d dash is not equal to 0, f of ab is not equal to 0, and this is not equal to 0. If you have case of failure, then you have to multiply. They use first semester results only. Let me take a few questions. Say you have r minus t plus p minus q equals 0. R minus t plus p minus q equals 0. What's r? Del 2z del x2. What is t? Del 2z del y2. What is p? Del z by del x. What is q? Del z by del y. Equals 0. Or this is d square, this is d dash square, this is d dash operating on z equals 0. Clear? This is r, t, p and q. Now this is d square minus d dash square. You can factor it, d minus d dash, d plus d dash, then plus d minus d dash operating on z equal to 0. You can take d minus d dash outside. What is remains is d minus d dash, d plus d dash plus 1 operating on z equal to 0. So this is a homogeneous factor. What is the solution? Complementary function. For this function of y plus 1x, you see, d minus 1 d dash. Auxiliary equation is m minus 1. You have to replace d by 1, d dash by d by m, d dash by 1. So m is 1. So what is the solution? Function of y plus mx. M is 1. For this, it is e raised to the power minus x, function of y minus x. You can see it. This is e to the power, this is a or b, e raised to the power minus of, if this is plus 1, it is minus 1 here. If it is minus 1, it will be plus 1 here. D plus d dash, so y minus x. D minus d dash is plus x. This is the complementary function. Next one. Say you have r plus 2s plus t minus 2p plus 2q minus z equal to 0. So what is it? R, what's R? Del 2z del x2. What's S? Del 2z del x del y. What is T? Del y2. What is P? Del z by del x. What is Q? Del z by del y minus z is equal to 0. Or you have d square 2dd dash plus d dash square minus 2d plus 2d dash minus 1 operating on z equal to 0. Let me take everything positive. Plus, plus, plus and plus. That can be another question, okay? So that it will be easy to understand. Now you have d square plus d dash square plus 1. So this is d plus d dash plus 1 whole square. See, what is d plus d dash plus 1 whole square? It is d square plus d dash square plus 1 square, okay? All the three. Plus twice ab, dd dash, twice b, bd, d dash square plus twice c, a, d. Okay, so it is d plus d dash whole square. You have repeated factors. So complementary function. For one factor only, what you have to write? E raised to the power minus x. It is plus x over here. Plus 1, so minus 1. Function of y minus x. Okay, then now we have square. So plus x times minus x, function of y minus x. This is it. This is the solution. If you have third factor, then x square e raised to the power minus x, f of function of new function f3 y minus x. Okay. Let me take one more question. So you have d dash, d minus 2d dash minus 3 operating on z equal to 0. What is the complementary function? C. This is d only. So d only means you have d plus 0 d dash. You don't need to write the non-homogeneous part. So it is function of y because m is 0, function of y. Similarly, d dash, I have already told you this is function of x. So d is function of y, d dash is function of x, and this is non-homogeneous part. So what is the complementary function? Function of y plus function of x plus e raised to the power 3x. This is minus 3 over here, it will be plus 3. Function of y plus 2x, because it is minus 2 over here, it will be plus 2 over here. You can see it. This is it. This is how we have to proceed. Now let me take up the particular integral part. Let me have this is a factor, and let me suppose that right hand side is function of 5x plus 6y. So I have a non-homogeneous partial differential equation, and right hand side is function of e to the power fx plus ax plus by type. So what I have to do is that complementary function you already know, e raised power 3x function of y plus 2x. Particular integral is e raised power 5x plus 6y d minus 2d dash minus 3. So what you have to do is you have to replace d by a and d dash by b. So this is e to the power 5x plus 6y, d is 5, d dash is 6, 6 2s are 12, minus 3. So it is e raised power 5x plus 6y divided by 5, this is 15, so minus 10. Okay, so what is the general solution? Z is CF plus PI. This plus this. This is it. Let me have, say you have d square minus dt dash plus d dash square minus 1 operating on z cos of x plus y. See, this is a non-homogeneous partial differential equation. There is no homogeneity. This is homogeneous one, this part is homogeneous, this is d square, d dash, order is true, but then order, no order. So this is non-homogeneous. What I have to do is that, let me take up, this is 2 equal, this 2, and these, I can take t common, no. Let me take, let me have d dash on. So what I have to do is that, let me take these two together. This is d square minus 1 minus dd dash plus d dash operating on z equal cos of x plus y. Now what I will get, this is d square minus 1. What is that? D minus 1 into d plus 1. Let me take d dash common, minus d dash, this is d minus 1. Operating on z equal cos of x plus y. Now, this is d minus 1, d minus 1. So it is d minus 1, then d minus d dash plus 1. Operating on z cos of x plus y. This is a non-homogeneous partial differential equation. What is this now? This can be written as d minus 1. It is d minus 0 d dash minus 1. This is a non-homogeneous partial differential equation part. Your m is 0. So you have, this is minus 1. So what is the complementary function? E raised power plus 1x function of y plus 0x. So function of y only. For this part, it is e raised power minus x function of y plus x. This is the complementary function. What is pi? Pi is cos of x plus y divided by d square minus dt dash plus d dash minus 1. For sine and cos, what I have said, you have to replace d square by minus a square, d dash square by minus b square, and dd dash by minus ab. So let me do that. I have cos of x plus y. Let me tell you, d square is to be replaced by minus a square. A is 1, so minus 1. This is 1, this is 1. D dash square is not there, and dd dash minus a into b, 1 into 1, so minus 1. Okay, a is 1, b is 1. So particular integral is your d square is to be replaced by minus 1, dd dash, so plus 1 plus d dash minus 1. Okay, now this is cos and this is d dash minus 1. You have to replace d square only, so you have to rationalize it. This is d dash plus 1 cos of x plus y, d dash plus 1 and d dash minus 1. It is d dash square minus 1. So d dash is to be replaced by minus 1. So d dash of cos x plus y plus 1 cos of x plus y, d dash is minus 1, so it is minus 2. Now what is d dash? D dash is del z by del y. So you have to differentiate this partially with respect to y. So this is minus sine of x plus y plus cos of x plus y by 2 or minus 2. So the general solution is CF plus PI. Okay. Let me take one more question. See, I have d plus d dash minus 1 d plus d dash minus 2 3 equal, operating on z equal, it is power x plus y. Complementary function, you know, it is power x, function of y minus x, it is power this. Particular integral x plus y d plus d dash minus 1 d plus d dash minus 3. This is also easy. Now let me make it a case of failure. If I will write 2 over here, 1 over here, okay, let me write 2 plus 1, okay, 2x plus 3y. This is a case of failure part. This is not a case of failure part. So for this I will use rule 1. For this I will use rule 2. Okay. So this is a complementary particular integral is replace d by a and d dash by b. It is power 2x 2 plus 1 minus 1. What remains is it is power 2x plus y d plus d dash minus 3. See, for that factor which doesn't vanish, I have used rule that I have to replace d by a and d dash by b. This I have done. Then another factor I have kept as it is. Now this is 1 by 2. Now this is a case of failure. When you replace d by a, d dash by b, this is f of ab is 0. So what I have to do is that I have to multiply by x. It is power 2x plus y. This is one rule. Another rule is that you have f d d dash, you have to differentiate it once, denominator. Another rule, this is the rule. You have function of ax plus by and you have f d d dash of any order, say 1, 2, 3. You have to, what you have to do, this will be same as this. If it's a factor of order 2, you have to multiply by x square by 2 and so on. If it is like this, what you have to do, another rule is that you have case of failure, differentiate this once and use f a, f b and multiply by x. If it is again a case of failure, differentiate again and multiply by x and so on. This is another rule. So this is it. This is about homogeneous and non-homogeneous partial differential equations. One thing which I have not told you is that what happens when we have a polynomial in x and y. Say you have d plus d dash operating on z equals some function of xy. One rule is general rule. You have to use once integrate x, replace y by mx plus c and so on. This is okay. This is a rule. You can use that rule, or you can use binomial expansion. If you have polynomial, what we were doing in first semester, we were using binomial expansion. You are taking the lowest degree term outside, then what remains is 1 plus minus some function of d. You are taking it to the numerator, operating by using binomial expansion and getting the solution. Same is the case over here. If you have a linear differential equation, homogeneous or non-homogeneous, and it's a polynomial, your particular integral is polynomial upon f dd dash. Now here, you take either d or d dash, it doesn't matter, it is your choice. But generally, if you have x raised power m and y raised power n, if m is greater, it means x is dominating, then take d, it will be easy for you. If y is greater, then take d dash outside. If you have homogeneous, if you have non-homogeneous, non-homogeneous part, say you have d plus d dash plus 1, say this is a non-homogeneous part. For homogeneous, you have only d's too, d plus d dash. Whether you take d or d dash doesn't matter. Here, d plus d dash plus 1. Here also, it doesn't matter whether you take d or d dash. Or you can keep it this only in terms of numerator, 1 plus d dash raised power minus 1. This is a single entity. You can operate it in terms of d dash, d by d dash or d dash by d. Because when you are taking d from this, what will you end up? D dash by d. Here also. If you take d dash outside, what you will end up? A factor of this type. Okay. So, it is your choice now. Whether you take d or d dash, or you take it in terms of d and d dash or d dash. Okay. So I will show one question in each case. Say I have homogeneous one is okay, because you know the general method also. 2d dash minus 3 operating on y. Operating on z equal xy. This is a question. Complementary function, leave it. Particular integral is xy upon d minus 2d dash minus 3. So it is now your choice. If you take minus 3 outside, what is minus 3? This is 1 plus d minus 2d dash by 3. 1 minus rather. Okay, now you can take it to the numerator and use binomial expansion. Minus 1 by 3, 1 minus d minus 2d dash by 3 raised power minus 1 xy. So what is it? 1 minus x raised power minus 1. It is 1 plus x plus it is square. See, it is square means d square you cannot operate. D dash square you cannot operate. Maximum you can operate once. But dd dash you can operate dd dash because it is both x and y. You can differentiate with respect to x or with respect to y first. So this will be a square b square minus 2ab. So minus minus, this is minus over here, so plus 2i's, it is 4 dd dash by 9 xy. Only these things will do. Xy. Now you can have the solution. This is minus 1 by 3. I hope you understand. See, This is 1 plus this raised power minus 1, and you have xy only. So xy means you have to differentiate this. You can differentiate this once, differentiate this once, differentiate this once. You cannot differentiate it twice with respect to x. It will be 0. You cannot differentiate this with respect to y. 0. You cannot higher derivative of d and d dash. That all will be 0. So only terms remaining will be these only. So what is the solution? Xy. Then differentiation of xy with respect to x, it is y upon 3 minus twice by 3 d dash, it is x, 4 by 9. See, d of xy, d dash of xy means d dash with respect to y, it is x. Okay, then d with respect to it is 1, so it is 4 by 9 only. This is the particular integral. So whenever you have polynomials, you can use this formula. Okay, whether, see, you may have factor of this type, then whether you will take d or d dash, this will be in terms of, I will just let you know how what type of factors you may have. See, for non-homogeneous part, you have only two factors, d minus d dash or d plus d dash. Okay, you can take d outside, this will be 1 in terms of d dash by d. Let me take plus. Okay, you can take d dash, this will be 1 plus d by d dash. This is your choice, whether you take x or y for homogeneous one. But as I have said, if x is dominant, you have x square y, you take d, then differentiate first, then integrate, because it will be easy. Don't integrate first and then differentiate, it will be very lengthy. So if you have non-homogeneous part, d plus d dash plus 3, say, I have just now shown. If is d plus 1, this is a non-homogeneous part, d plus 1, then you can take it upside. If it's 1 plus d dash, you can take it upside. If it is d dash, d plus 3, d plus d dash plus 3, then I have already shown. These are the cases only. Okay. Or if you have this one, you can also take d outside, you can have d dash by 3d and 3 by d. You can choose this one. You can choose d dash also outside. This will be 1 plus d by d dash plus 3 by d dash. This is your choice. These are only choices you have left with. If you have a polynomial of degree, or whatever degree in x and y. Okay. So let me now come to non-homogeneous, non-linear differential equation. Homogeneous and non-homogeneous differential equations we have finished now. Let me come to non-linear, linear partial differential equations. You know linear differential equation, Lagrange's linear differential equation. PP plus QQ equal R, right? What about non-homogeneous? What is the non-homogeneous partial differential equation? This is represented by f of x, y, z, p and q equals 0. A non-homogeneous partial differential. This is also a non-homogeneous homogeneous partial differential where you will have p, q, x, y and z. You have seen this. But what is the difference? Here p will be of some other degree. Say p square, p cube, p4. Q has a degree. Here P and Q have unit degree, 1 degree. And you have product of PQ also. If you have such case, degree of P is greater than 1, degree of Q is greater than 1, and you have product of PQ also, then we say it is a non-linear partial differential equation, right? For example, you have, say, Z equal PQ. P square Q square. Okay. And first of all, there is a product PQ. So this is a non-linear. So you have P plus X equals Q plus X. This is, say you have P square plus Q square, non-linear, right? So this type of equation. So you have only x, y, z, p and q, and you know z is function of x and y. You have two independent variables x and y. Now it is solution, uh, complete solution, complete integral or complete solution is given by f of x, y, z, a and b equal to 0. Means if you have two independent variables, the number of independent variables replaced by, if you have as many constants as the number of independent variables, then the solution known as is known as complete integral. Then the solution is known as complete integral. You have two constants, two independent variables and two arbitrary constants. The solution is known as uh, complete integral. Now, before going to the complete integral, before going to the non-linear differential equation, I have promised you in my first lecture that whenever I will take non-linear partial differential equation, I will take up formation of partial differential equation using by eliminating arbitrary constants. I have shown you formation of partial differential equation by eliminating arbitrary functions, not arbitrary constants. I will be first taking up formation of partial differential equations by eliminating arbitrary constants. So let me take up first that, and then I will come to this part. Say you have z equal ax plus by plus a square plus b square. Z is ax plus by a square plus b square. You have to form a partial differential equation by eliminating arbitrary constants a and b. What you will do, you will write del z by del x. What is that? A. Del z by del y. What is that? B. So this is p and this is q, right? So what is the solution then? Z equal px plus qy plus p square plus q square. So you have formulated a differential equation, partial differential equation in terms of p and q, and you see I have just now given you a definition. This is a non-linear partial differential equation. Usually by eliminating arbitrary constants I get a non-linear partial differential equation. Let me take a few more questions from the book. Okay. Now remember this is known as Claret's form. Whenever you have differential equation f of z equal px plus qy plus f of pq, answer is always z equal ax plus by f of ab. This is a general rule, Claret's form. So remember it once for all. Let me take up one more question. Z equal ax plus 1 minus ay plus b. See, this is another type of equation. You have two arbitrary constants a and b. Let us eliminate them. This is 1. What is del z by del x? Is a. What is del z by del y? Is 1 minus a. So let me use 2 and 3. From 2 and 3, I will get del z by del x equal 1 minus a del z by del y. Sorry. Del z by del y equal 1 minus a, but your a is del z by del x. So you have del z by del x plus del z by del y equal to 1, or p plus q equal to 1. Okay. P plus q equal to 1. This is a linear differential equation. This is p plus q equal to r. But I will show you I can solve this by using non-linear methods also. Say if you have a equal to 1 minus a square. Instead of a I have a square. What I will get? Del z by del y equal to 1 minus del z by del y whole square. So del z by del x whole square. So I have p square plus q equal to 1. This is a non-linear partial differential equation. So it depends. What is the question? Okay. Next one. Let z equal x minus a square plus y minus b square. X minus a square, y minus b square. So let me differentiate partially. I have to eliminate a and b. So let me differentiate partially with respect to x and y. What is del z by del x? It is twice x minus a. And this is p, you know. What is del z by del y? It is twice y minus b. This gives us x minus a is equal to p by 2. Y minus b equal to q by 2. So let me use 2 and 3 in 1. Use 2 and 3 in 1. What I have? Z equal to p square by 4, q square by 4. So p square plus q square equal to 4z. Let me write down here. From 1, what I have got from 3 questions. Ax, px plus qy plus p square plus q square. Then z equal or p plus q or p square plus q equal to 1. Then this one is p square plus q square equal to 4z. Okay. Now one more question. Elimination of arbitrary constants. Let me take up one more question. Say I have These are very easy questions. You can solve it yourself. Z equal x square plus a y square plus b. X square plus a y square. So what is it? Del z by del x. 2x y square plus b. This is p. Del z by del y. 2y x square plus a. Right? So this gives us y square plus b square. P by 2x. X square plus a square. Q by 2y. So let me use in 1. So from 1 I have p square by 4x square into q square by 4y square. So p square into q square equal 16z x square y square. Is it okay? P by 2x z equal, why have I written 4? Oh. You see, x square plus a square is pq by 2y. And this is p by 2x. So what I have to get, what I will get is that 4xyz equal pq, a non-linear partial differential equation. So let me come now to the partial differential equation. So this is 4xyz pq. Remember these. Now what I have said is that a non-linear partial differential equation, a non-linear partial differential equation is represented by function of x, y, z, p, q equal to 0, right? You see, we have 4 different methods. Standard form 1. Say you have z equal ax plus by f of px qy f of pq. As I have said, this is known as Clairaut's form. Clairaut's form. It is, if you have to solve this equation, you have to replace p by a and q by b. I have shown you one example. I will be showing you 4 more examples. So its answer is ax plus by plus f of ab. Just like this question. I have a question say z equal ax plus by plus a square plus b square, or z equal ax plus by plus ab. Answer is z equal px plus qy plus pq. Right? This is the Clairaut's form. Standard form second. So here all the components are there. Z is there, x is there, y is there, p is there, q is there. Right? Standard form C. 2. Say you have only 2 things, f of p2 equals 0. Only instead of 4 or 5 things, you have only p and q. This is one form, right? I will be showing you what is the solution, how we will be solving such equations. Standard form 3. You see, this is question of this type, p square plus q square equal 1. This is f of pq. This you have just like seen. If you will take the reverse question, if you take this question, answer will be the question which we have just now done. F of p, q and z equals 0. F of p, q and z. So if you have this question, I can solve this. This is a form of third form. P, Q, Z is there. Solution will be, it is original question which I have done just now. And standard form 4 is that you have f of x, y, z and p and q. Z is absent. In this case, Z, X, Y are absent. In this case, X, Y are absent. In this case, Z is absent. And this is of the type, you may see if you book f of xp equal f2yq. We can separate these, x and p one side, y and q another side. These are 4 methods. And there may be some questions which are not of these form. Then we use the general method known as Charpit's method. Charpit's method. You have to remember it is auxiliary equation which is very big. I will be writing it on the board. I will not be rubbing it off because I will be using it quite often. So, Charpit's method, I will be giving you notes also. I will be discussing all these methods in my next talk. Thank you.